start recording again. Oh, and lunch is here. Great. So I put this link here. I'll start slowly as this lunch situation gets clarified. We are going to just go to that link again. Takes you here where there are three notebooks. Sorry.
So we just go back.
Mm-hmm.
Can we save like the comments we made throughout on this or no?
Yes. In fact, if you've been typing stuff in, etc., then you can just do save a copy and drive on the notebook. Oh, sorry, on the notebook?
Yeah, like
In the file menu, you can do save a copy and drive.
I don't see file. File? Oh, alright. It's in the bar that's editor. Right here. It's the bar when you say open column. Oh, I think one step. Sorry.
You didn't open it in Colab?
No, I didn't. This
Scroll all the way to the top. No, wait. That shouldn't.
it isn't
Hold me the.
What was the website again?
Give me a second.
It didn't work for you? Oh, I guess that sounds like a good website.
This is wild.
I just clicked on module 1 in Colab and then started putting comments with the hashtag.
It says cannot save changes.
Sorry, can I just?
Okay, now you're all set. So So what I did was it said cannot save changes here, and then I clicked on it and it said save a copy and drive, and then it opened it, and now it's saved in your thing. I'm not 100% sure why you're not getting the file edit, etc. I don't know. Maybe there's like something here in the gear if you click on it that will show you that made you hide it. I've never seen that before, so I can't be super helpful. But yes, okay, so the original URL, I'll go back to that in a second. There we go. Here's the. Go ahead, that's perfectly fine. I have these all open in different tabs. That works too. But I actually know these URLs by heart anyway, so. Okay, am I recording? Yes. All right. So this URL takes us to GitHub, where we have the three modules, and we pick the second module. Now, it just dawned on me that I don't remember how I set this up, but we get the notebook, and we click on Open in Colab. Can you actually, can one of you just prop the door open a little bit, if not all the way, just because, like, I see Dan isn't in here, so like the door is locked, I think. I don't know. Okay, so let's just start. We are going to now build a corpus with JSTOR and have an introduction to Pandas. So when you want to analyze data, no matter what the data are, you have to acquire it somehow. So either you're out there measuring in the field, or you have surveys or something, or like a GPS tracker that you use to collect the data, or you get it from the government. Somehow the data come from somewhere, and you have to get it into an environment that works for you to work with it. So if the data is text, then oftentimes we talk about it as a corpus, plural is corpora, and you build up a corpus of text. Typically, the text is made up of documents, Document is an arbitrary thing. If you work on, well, you shouldn't anymore, but if this were 5 years ago and Twitter were still an active site of research interest, then you would be able to research on Twitter where each tweet is a document. Typically, a document will have some kind of metadata associated with it. So in the example of a tweet, you have the date when it was tweeted, who the person is who tweeted it, what the ID is of the tweet. Every tweet has a long number that is unique to that tweet. Other metadata tweets had, who knows what they have now. If the tweet is a response, what the ID is of the response of the tweet that you're looking at is a response to. If it's a quote tweet, what is the ID of the tweet it is quoting? What is the URL to the picture, if there's a picture involved, all these sorts of things. The reason that you want kind of a corpus and you want to do this sort of stuff is because you want your documents to have a predictable structure, which is to say, if there is an author of every document, you want it to be the case that if every document is like a dictionary, you want it to be the case that the author key always tells you what the name of the author is, and not on some documents it's called the author key, and on other documents it's the writer key, and on other documents it's, as we'll see today, it's called creator. You want to make sure that that sort of stuff is consistent. If all your data is coming, if the whole collection of the data is coming from one place, then typically you have the luxury of it being all the same sort of shape. If it's from multiple places, things can get a little bit hairy, and one of the steps you have to do is to harmonize everything so that the data all look sort of the same, so you can work on all of it at once. So I do want to underscore that what we're doing today is a luxury, that we are getting data that are this clean and this easy to use. Often it's not this easy. And even so, with like these best circumstances, we are going to see that there are still problems. Okay, so JSTOR, I hope you are all familiar with it. If you aren't, get familiar quickly. But they provide, the nonprofit that runs JSTOR is called Ithaca, and Ithaca provides a tool called Constellate that facilitates sort of doing text analysis of the JSTOR archive. It's a little bit more than that, but effectively the JSTOR archive. There are plenty of places to get textual data from. I have a link here to the text and data mining guide to do so. If you want to work on newspapers, like contemporary data, then ProQuest's TDM Studio will give you access to some of that. Among one of the most important things that TDM Studio can do is let you have access to yesterday's New York Times. So you can do text data mining on the entire run of the New York Times, which is a good place to start with things. We are going to download our data from Constellate today. In TDM Studio, you don't download the data, you work on one of their pretend computers. It's like, so the way that Colab is working on a pretend computer that Google provides for us, TDM Studio works the same way. They create a pretend computer, and then they let you work inside that pretend computer, and then you can take some stuff out, but it's limited. Anyway, long story short, if you want to work on newspapers, email me. So Constellate is pretty straightforward to use. I'm now realizing that this may be a little bit tricky in one way, but hopefully it'll work. Yeah, let's see how this works. Okay, so you go to constellate.org, so constellate.org, and you see a page that looks like this, and you log in the top corner, and it says blah, blah, blah. You log in with Google. And hopefully you are already connected to your Columbia stuff. So you get logged in with your Columbia stuff. So far so good? Yes?
Sorry, can you just give a second? I'm not logged into Consulate. It says login JSTOR credentials.
At the bottom, there's a button that says login with Google.
Okay.
That's what you want to click on. So you skip all the JSTOR stuff. Then we have these pictures and so on. OK, that's right. We get to here. So it looks a little bit different here because I'm zoomed out somewhat. But if I zoom in a little bit more, there, this is what it looks like in the pictures. But I'll zoom out a little bit because, OK. So Consulate is a tool for doing data analysis inside of their web-based environment. It lets you do a lot of simple stuff. We'll see today that even the simple stuff can get complicated really quickly in the sense that the conclusions can get complicated very quickly. But they have this whole thing here that we do not subscribe to. All we are using Consulate is to build a data set, pull the data out, and then never use Consulate again. They want us to use it to do the computations and stuff. If you want to try that out within the limits of their free tier or whatever, go ahead. We won't be doing that today. So we are building a data set. So we go to build a data set, and sorry, I did that kind of quickly. So you just click on the build a data set button, and then you come in here. And you should be logged in. It should, it says, we think you are at Columbia University, facts. And then they start you out with this sort of like test data set, but we want to go straight to, sorry, I should announce these better. We want to go straight to browse titles because all we want is the Journal of Political Economy. That's it. I mean, that's already a ton. So you click on browse titles. Unfortunately, you can't just type in Journal of Political Economy here. It would be great if you could, but it doesn't work for some reason. Or it doesn't work for me. Maybe it'll work for you. Instead, you click on Browse Titles, go to J. Oh, boy. OK. J. Takes a little bit of time to load. Then I'm just going to do a search and jump all the way down to Political Economy. And we have the Journal of Political Economy. OK? So far, so good? Now we see here that the Journal of Political Economy is provided by JSTOR, and there are 13,000 documents associated with it. And it's from 1892 to 2017. You'll say, but it's 2023. What if I do if I want newer JPE documents? The answer is you have to go to the JPE website and download them by hand. Sorry. So you have to download the last 5 years by hand because JSTOR doesn't have them. Other journals they're better about, not this one. So we tick Journal for Political Economy, and then confusingly, there's no like save button or anything. You kind of just scroll all the way to the back to the top, and then do search journals. And now it'll say Journal of Political Economy down here. So far, so good. You all have to do this, otherwise this isn't going to work. Because I'm not going to be emailing you this data. I can't email it. It's too big. So you have to go to Browse Titles, pick Journal of Political Economy, and you should see something like this. And it's updating it, and it's saying, OK, this is the number of documents over. I don't know what it's telling me here. Yeah, this is the number of documents. That doesn't make sense. Why is it 8.9? What's that?
It's updating.
It's still updating?
Yeah, it's just slow.
It's just slow? Maybe it's because we're all pounding it at the same time. OK, let me see about getting you the data in an easier way. Machika, can you pass me the sign-up sheet? Oh, this is, I'm going to have to delete this section from the recording so people don't see all your email addresses. SKD2167, AV3164, SLS2312, CG3456.
I actually did get the
IQ
data online.
215 QM 2174 PB 2929. Okay, in an orderly fashion, please tell me your uni if you do not see it here. Yes?
FA2639.
2639. Next.
HRR 2120.
2123.
YL5546.
YL
Yeah.
5546. Is everyone here? KR 3079.
Mine just downloading. When I refresh the page, it's
This-
all here.
Okay, this will actually be better in the long run because if we do it this way, I should have thought to do it. Okay, does everyone see their email address up here? Raise your hand if you don't see your email address here. Or your name. Okay. So I'll show you how the download works, and hopefully it will work. The main download that you get from JSTOR is over 2 gigabytes. It's almost exactly 2 gigabytes in size because it includes unigrams, bigrams, and trigrams, which are, unigrams are how often a word appears in each article. Bigrams are how often a combination of 2 words appears in every article. Trigrams is 3. So this is a ton of extra data. When I remove the grams, it's just 70 megabytes. So that's what I'm emailing you all. And you will get this file in a second. And I have to remember to delete this whole section from the video. Delete everyone's email. Okay, but I'll walk through the rest of the consulate thing. So,
If you refresh it,
okay, there you go. So, so we have here the JPE goes back before 1900, but I mean we're not preparing anything for publication here, so we can start with 1900, and then you do blah blah blah, and you do build. And then add a dataset nickname, JPE live at workshop. Do confirm. You can name it whatever you want. Here's the one I used the other day to prepare this. And then other people have asked me for JPE, so I already had the dataset anyway. So it builds it, and then this will take a second. But then when you go to download, you can download it in a couple different formats. If you do more download options, that's how you get the full download. It says 620 megabytes. That's not true. It's 2 gigabytes. I've done this. I know it's 2 gigabytes. I don't know why it says 620, but whatever. So this is what I would have had you download, but then this still has a whole bunch of extra information that you don't need, namely the unigrams, bigrams, and trigrams. And actually, all we're going to end up working today with is the metadata, and I will show you why in a little bit. But for now, you have the file. So okay, so we have to do things a little bit. Okay, so that's the end of Consulate. So under normal circumstances, you would have clicked all on that, and you download something, and you get this like really long, funny-looking file name, and at the end it's .jsonl, .jsonl.
Do you
Or
have any that you have downloaded for us to see as reference of what it looks like?
yes, the file I just emailed you
Oh.
is what it looks like.
Oh.
Don't open it. Like, I mean,
Oh, I tried to.
like yeah, well, sure, I can show you what it looks like. It is not interesting, but sure.
Curiosity.
Give me a sec. I know this is illegible. This is what it looks like. So it's a huge file. It's just a bunch of text, and you know, like, it's not meant for people. It's meant for computers.
Okay.
So, but you can see a couple things here. I mean, like this is I show this in the thing in a little bit, but you can see, oh hey, this looks a little bit like we were just working on in the previous module, because you can see that this is a dictionary, and a dictionary with a key called creator. And what is the value of creator? It's a list with 2 strings in it. And then what's the next key? Date published. And it has a value of a date that's saved as a string. What's the next key? Doc subtype, ... And then you see these backslashes, because slashes have to be escaped in JSON, which is the file format that this is. This is what needs to be photographed, because this is the, like, man, we're coding super hard. This isn't the web. This isn't anything. This is just, you know, just us in the metal. Just we're coding. Just a stream. I can do this again so you can see it zoom past. Okay. All right. So that's what we downloaded, is that file. So let's go back to the notebook. And then I'll just close all of this, because we aren't going to be using Consulate anymore. Because, oh. I did do this all already.
Oh, done.
You have this file on your computer now. So what you have to do is you have to get the data into Colab. So earlier we saw this X thing for the variables. This folder gives us a little file place where we can put our little files, right? So I am going to open up where my version of that file, which is in projects, and then in data club, and then in WIS, and then in data. And I just take this file and I drag it into here and drop it. And I get this warning: ensure your files are saved somewhere else. So what this is doing is this is uploading my file that's on my computer and on all of your computers now, because I emailed it to you. It's uploading that file up to the pretend computer that Google has furnished you. Google does not make this computer available forever. It will close it and destroy it after a certain amount of time. So stuff that you need saved, so the notebook is always the notebook. But anything that isn't the notebook, that is data or results or anything like that, you have to pull out or save on your, or already have saved on your computer. You have this quote unquote saved on your computer because you were emailed the file by me. or you created it yourself in Consulate, or whatever. So we do ensure your files are saved elsewhere, OK. And then it'll take a second for it to upload.
So should we download it right now? Through Drive?
The file I emailed you, go ahead and click through on that Drive link and download that, and then drag that into here. It's a slightly odd way of doing this. I wish I could do it a little bit differently, but hypothetically, I'm giving away a little bit here. Hypothetically, this data has the entire full text of JPE on it, which is not something that I want floating around on the internet, because it can get tracked back to me that made it float around on the internet. So if I did the normal things that I would normally do to share data, with something that ends up on YouTube, anybody could go download it, and then I'd be in trouble. So I made it a little bit more complicated, but the end result is that you have a file on your computer that you can drag into this little box here, and then you'll get JPE full nograms.jsonl here. Okay? Is everyone up to this point? Raise your hand if you've uploaded the file already. Okay, so I'll give it a little bit more time. So we had the question about, like, you all tried to open it on your computer and it probably complained that you don't have an application associated with JSON-L files. JSON-L or JSNOL or JSON-L is line delimited JSON, or JSON lines. When you get data, you'll get it in tons of different formats. CSV, in the Consulate page, there was an option to download things as CSVs. CSV is comma separated values and basically is an Excel spreadsheet where everything is separated by commas and returns. JSON is basically like dictionaries, like a list of dictionaries, which is why that's what it looked like. JSON-L, instead of having dictionaries separated by commas with brackets on the outsides, it doesn't have the commas or the brackets, and just every line is a new value in the list of dictionaries. How are we doing now?
I can't upload the file.
You downloaded it to your computer?
Yeah, I cannot insert it there, like in the.
Into here?
Yeah.
You can click on. Did you click on this? This is another way to go around uploading.
There, yeah, I tried both ways.
And it doesn't show up, or does it give an error? If you reload, it might show up.
It's waiting. Yeah, I tried opening it because mine is just saying loading here, so it takes a while. Okay, maybe I'll wait.
Yeah, it should. The name should show up down here with a little blue spinny.
Try deleting it and then re-downloading the file, because it happened to me as well.
Yeah, it can be a little bit tricky, but I'll show how to do it one more time. So we go to, or I'll show not with the drag and drop, but another way of doing this is through this. Madiha, are you asking a question?
I'm saying slower.
Slower, okay. So another way of doing this is by clicking on this upload icon. And then navigating to where the file is and clicking on it and do open. You'll get this warning. Those of you who are having trouble, have you at least gotten this warning? Raise your hand if you are having trouble, please. So you're all fine. You all have it uploaded. Okay, all right, great. All right, so Madiha will help in the back there. Okay, So that's a little bit about file formats. This file is being saved as JSON-L, which is basically a list of dictionaries like we saw when we looked at the screen, or when I opened up the file or scrolled through it. And now we want to read this file into Pandas. Pandas is the first thing that we're going to import. It's the first thing that we're using today that is not built into Python. Pandas, if you install Python on your computer, you will have to install Pandas separately. Pandas already comes pre-installed in Colab environments, so we don't have to install it separately. We will install software later, but for now, Pandas is built in. Pandas is a great, friendly data analysis library, and we can use it to look at tabular data, like an Excel spreadsheet. In fact, you can import Excel spreadsheets into Pandas. So, all right, so let's go about getting data into Pandas. We have to import Pandas, and then we import matplotlib also, which is a plotting library. So that's what these commands, let me zoom in a little bit, make things a little bit bigger. We have Pandas, we import it as PD, and then we have this import here. Yes, Madiha?
I think we should pause for just a second, and I just want to check. Raise your hand if you imported your files. If you uploaded your files into Colab.
I did, but I wonder, because I have a lot of files, I don't know what I did wrong.
Okay, we can take a,
I think we should pause for just a
all right, we can take a break.
I've done this before, and I can't
Okay, that's fine.
I'm forwarding you the email that I sent to Sarah. So just disregard the email that
I've done this before. I've done this.
Oh, how on earth did they get there? Okay. I won't touch it. I won't touch it.
We'll talk about that. Okay. Anybody having difficulty with the file still? You're all set?
No, I didn't want to. Shit, I was supposed to go for ice cream.
So after they upload their data, is the same as
I haven't done it yet. I just I understand. Yes.
So to import Pandas PD, the PD part is like we can just pick anything, right?
Yeah.
It's just a name.
Okay, so I'll start, but I'll still do a little bit of talking. There won't be any like code stuff happening. Like I said, Pandas is not built into Python. You have to import it separately. So, and matplotlib, which is a library for making graphs and stuff, is also not built into Python. You have to import it separately. Again, if you install Python on your computer, you have to install these things. You also have to install these things. If you are not on, but in Colab, Pandas, and matplotlib come pre-installed. So you're off the hook for that. import pandas as PD. This is a convention, which is that apparently typing in PANDAS is too much work, so people just import it as PD, so they can refer to Pandas, the library, which provides a bunch of functions and a bunch of different things, as just PD. The same thing, people don't want to have to type in matplotlib.pyplot every time they want to plot something. They want to just type in PLT. We're not going to mess with this until the end, until the third module. But that's what these two lines mean. Import Pandas, import the Pandas library, which Colab provides already installed, but you have to import it explicitly as PD. Same thing with matplotlib. So this should work. And is the first actual bit of code. So we've uploaded the file. We have the file here, and that. Now, the next step is to read the contents of that file. So you see it here, written out like this. If this doesn't work for you, I'll show you another way to go about doing this. But if you press play, under ideal circumstances, it'll take a second because it's reading in 70 megabytes of data into memory, and you'll get this. Does this work for everybody? No. What error do you get?
It says the name error.
Okay. Try this then. If you get the name error, go back to the little file thingy. So click on the folder to get the file thingy. Click on the kebab menu here. What did I just do? Content. Shoot.
Oh my god.
Content. It's in content. Stop. You don't want to get here. I'm just going to reload.
I did, and it wasn't.
Yeah. I mean, I know now how that happened though, because I just did it. If you click on the kebab menu and somehow I managed to go up, but instead you want to click on the kebab menu and do copy path. If you do copy, so you have the file highlighted, and then this little kebab menu shows up, and you click on it and you do copy path.
For us, we just ran the sentences before, and then we ran the second one, and it worked.
Say that again?
For us, when we ran the number one, the sentence before the import, we ran that, and then we ran the second one,
And it worked the second? Yeah, okay, so it was a different error. Oh, the name error would be that Pandas might not have been loaded. So it's the same thing. If you do copy path, it's the full path to the file. So /content/jpe full nograms.jsonl. And it works, like if I can just do this. So that's the safest way, but typically the Colab will already know that you're in the content folder, and this all will work that way too. But the important thing is that you see this thing show up. So is that the case? Does everybody have this? Raise your hand if you do not have this. Okay. How many people? Raise your hand if you do not have this head thing show up. 1, 2, 3 people. Okay, let me run over and check.
for a KDOC program. And those are severely underpaid jobs, and it's still like so high standards for getting in.
Okay, so it's not at all surprising that the most like problematic thing is uploading the data. Like that is almost always going to be the case. I tried to make it as easy as possible. But again, the specific nature of not wanting to have this data just floating around on the internet is why this is a little bit trickier. Under normal circumstances, the data would be on a server that you can just download it, and it would be like 2 lines of code to just go get it, and that's it. But this is a little bit difficult, a little bit different, where I have to email you the file, and then each of you has to uniquely upload the file, et cetera, et cetera. But let me explain what happened here. So we ran 2 commands. df equals pd, pandas, read JSON, read a JSON file. Then the first value here, let me zoom back in. The first value is the path to the file. So that path is the content folder, and then the name of this file. And we can see that here. This is the content folder. It's up here somewhere is a folder called content, and these are the contents of the content folder.
If you're on a Windows device, this may be on the right-hand side, but it's the same.
Yes, it's the same thing. It's just showing what the files are.
And when Mustard says kebab menu, that is the 3 dots that appear when he hovers over one of those files.
Yes, this is the
You don't
kebab
want to
menu.
click on the arrow or on the file itself. You want to click on the 3
Yes.
dots.
If you click on the file, nothing happens. But yeah. So this is the kebab menu. So as it was originally with just JPE, full no-grams, this should work for most people. But if it doesn't, then you can click on the kebab menu, copy path, and then paste that in instead. And all that actually does is it adds /content/ to the beginning. This is handling file stuff, which unfortunately is very important, but unfortunately we don't have time to talk about in great detail. Lines equal true. So read JSON, as you can tell, is a function because it immediately has these parentheses afterwards. And here it's taking 2 parameters. The first parameter is the path to the file. And the second parameter is what's called a keyword argument, because it has a keyword, lines, equals, and then we pass in a value for that keyword, true. All lines equals true means is that it's a JSON-L file where each line is a new dictionary, as opposed to a regular JSON file that is commas. And then df is the convention for data frame. So Pandas provides this type called a data frame. And a data frame is we learned about strings, booleans, numbers, et cetera, et cetera. Data frame is a specific type that is created by Pandas that has a million cool functions and cool things that you can do. So it is not a basic Pandas, or not a basic Python type. It is only available in Pandas. Among the things a data frame can do is a data frame has a built-in function that's called a method, or it has many of them, but the first one we see is called head. So if we do df.head, parentheses, parentheses, we get the first 5 values of the data frame. And you see that this looks something like an Excel spreadsheet with 5 values, 0, 1, 2, 3, 4. See, it's 0 indexed. So that's why it starts with 0. And you can see there's a column called creator, a column called date published, a column called doc subtype, doc type, et cetera, et cetera, et cetera. So we have this variable that holds the contents of our file, and this is all saved in memory now. We could delete the file now, and everything will be fine because the contents of that file are saved as the data frame df, which is saved in memory. If you are dealing with an enormous file, like multiple gigabytes, you can't really read all of that into memory at once. You don't have enough RAM, perhaps. So things get a little bit more complicated, but I tried to keep things easy here for today. OK, so let's do some quick initial analysis. We already saw dot head with parentheses. That's a method. When it doesn't have parentheses, dot something, that's a property. So data frames have a property called columns. And if we press play here, then we see the value of that property, which is a list. I mean, it doesn't look entirely like a list, but it's effectively a list that is of all the columns. And I think there are 27 or 30 columns. Although that doesn't look right here. There are plenty of columns. You can see them here. And then we can also see what types are in these columns. Pandas guesses what the data type is in every column. We see here that the result is not particularly helpful because Pandas says they all look like objects. We have no idea what an object is. Object is just generic. But there are a couple things where it does say, OK, page count, it says, is int 64. That stands for 64-bit integer, which means that it's an integer between negative some big number and positive the same big number, except the positive version of it. That is 2 to the 64th. And we see publication years also in 64. And we see that volume number is also in 64. What this means is that in general, Pandas doesn't know what is in these columns, but these columns all have numbers in them. So that's what's meant, and integers specifically, that are between negative 2 to the 64th and 2 to the 64th. Word count is float 64, which is a non-integer between negative 2 to the 64th and 2 to the 64th. I don't know why word count is not an integer. Who cares? It just isn't. It's a float here. Doesn't make any sense. Could be, yes. It could be because for some things that there is no word count. So we had the bracket operator, and I'll talk a little bit more about the bracket operator in a little bit, that lets you access either things by index number, 0, 1, 2, 3, 4, or by the property name. So in Pandas, with the bracket operator, if you pass in one thing, that's a column name. So what df doc, so let's do this step by step. So if I do df doc type, we'll see that it gives me a list that's 13,000 things long. And it gives me the doc type for every single one of them. So this doesn't look like a list. Remember, lists look like bracket, value, comma, 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 whereas this is a list like this. It's not actually a list, but I'll get into that in a little bit. And it tells us that the length is 13,473. The type is object, and the name is doc type. So now if we do, so that's what happens if we do just df doc type. I'm going to delete this. Now, like I said, that isn't a list. It's actually a series. Pandas provides two types: data frame, which is x by y, and series, which is just a column vector, basically. It's just one column of information about anything. So that's why it's a little bit like a list. Like you can imagine a list as a row vector, because it's blah, 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 comma, blah, 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 comma, blah, 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 comma. Whereas a series, one way of thinking about it is as a column vector, because it's blah, 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 new line, blah, 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 new line, blah, 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 new line, up and down. Series and data frames have a method, which means that you do dot something with parentheses, called value counts. So df doc type means create a series that's just the doc types, and then execute the value counts method on it. And what do we get? We get a list of the different kinds of values in the doc type column, and then it tells us how many of those there are. So I have no idea what doc type means. I don't know what JSTOR was thinking when they coded in doc type, but I can tell you this. There are 3 different kinds of doc types in this data set: article, document, and newspaper. And nearly everything is an article. There are 239 things that are labeled as a document, and there are 10 things that are labeled as a newspaper. If you want, on your own time, to go and figure out what they mean by a newspaper that got published in JPE, go ahead and figure that one out. But this is just to show that this is a way of getting a sense of all of the different values of doc type. We know there are only 3 because only 3 things show up here. We didn't know that from looking at this. We didn't know that from the list, which just said article, 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 and then a couple periods, and then article a bunch more times. But through this, we know that there are 3 distinct values. 1 is almost all of them, and then the other 2 are tiny little chunks. Another method is describe. Describe works best on numbers. Since this data frame only has 4 things that are numbers, I picked publication year. So if we press play, we get some basic summary statistics about that column. So we see that there are 13,473 total rows. The average publication year is 1951. The standard deviation is 30 and change. The minimum is 1900. Remember, JPE started in the 19th century, but in my search term, I only picked 1900. So the minimum is 1900. The maximum is 2017 because JSTOR doesn't have the last 5 years of JPE. They're embargoed. So we'll make use of this in a little bit. And here's where I ran into trouble organizing this because I was like, describe the word count. Okay, 13,468. Okay, well, that's not the same here, but okay, no big deal. The minimum is 0. Oh, so there are things that have a word count of 0. Okay, but the mean is 3,800 words. That strikes me as low. Like I would imagine articles are longer, but I'm not an economist. My field has longer articles. It's not better. I mean, it is, but whatever. So let's look at the full text column. Here's where things got very problematic. So df full text, if I just run df full text by itself, I get a long list that gets truncated, so I only see the tippity top and the bottom of the value for full text. If I add is null, then I say take that series, take that column vector, and instead of printing the value for full text, tell me if it's null or not. So if it's empty or not. So true, false, true, false, true, false, true, false. And then I do .sum. So actually, let's do this by itself. So I'll just comment out sum right now. And we see we get false, 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 true, 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 right? So we get a column vector that is nothing but trues and falses. Right? So that means that for 0, the first row in the data set, the full text is false. There is no full text for it. For the second one, it's true. For the third one, it's true. And then et cetera, et cetera. And then I add another method, because series have a method called sum. So false and true are also understood in Python as as 0 or 1. False is 0, 1 is true. So if I do a sum on a bunch of falses and trues, the answer is that I'm getting the number of trues. So if I run the whole thing with sum, oh, so I downloaded 13,000 articles and 10,000 have null for full text. I wanted all of the JPE full text. Actually, I only got the full text of 3,000 articles. I wanted 13, I got 3. Okay, so let's figure this out. So here I just is a little bit of adding around, but I divide this sum by the length of the entire data frame to find out that 75% of the entries have no full text. So this is not what I was planning on doing for today. Luckily, I found out something more interesting to do. But in the meantime, you are going to join me on the journey I took a couple nights ago while I was putting this together and see what I had to do to figure out why this was the case. So maybe there's a whole bunch of bum data in here. So let's see, for column name in full text creator publication year. So iterate over all 3 of these column names, and for each of these column names, print out what percentage of the data set has empty values for each of those things. And the answer is 75% of the entries have no full text, 12% of the entries have no creator, 0% of the entries have no publication year. So this suggests that it's not just a bunch of the data is just junk. It's just, for some reason, a bunch of articles do not have the full text. Even though when I downloaded it, I ticked the little thing that said full text, please. So let's plot a histogram of the publication years for everything, and this is tricky. I'll explain in greater detail the syntax here in a little bit. It's down the slides a little bit, or down the notebook a little bit. But what this is plot a histogram. You have to read from right to left sometimes. Plot a histogram of all the publication years of all of the rows where full text is null. So if we do that, we see, well, what do we see? We see that the null full text only starts in the 1920s. If you know anything about US copyright law, you can guess. Madiha, you're dying to give the answer.
Dying to that is when the majority of texts went into public access.
Yes. Stuff from before 1927 is in the public domain. Stuff after 1927, I think it's 1927, is not in the public domain. So we see that I don't have any of the non-public domain stuff. And if I plot a histogram of the stuff I do have the full text of, oh look, it's everything from 1900, when I started my search, to 1927 exactly. That does have the full text. So I thought I downloaded the entirety of JPE. Turns out I only got the full text for a part of it. We can also see this if I do describe. So again, describe the publication year for the subset of the data that is just the stuff that does not have full text. We see that the minimum, or that does not have full text. We see that the minimum is 1911, maximum is 2017. If I do for the stuff that does have full text, we see that the minimum is 1900 and the maximum is 1927. Boom. So I only got the public domain stuff. So that's irritating, but that also explains why the file is only 70 megabytes. I could not figure out why it was so small. And the answer is because I did not get what I wanted. I wrote to JSTOR. They were like, you fool, you know what the problem is. We have this thing called data for research where you're supposed to click on it, fill out a little form that says, please give me all of JPE. I know I can't get this through Constellate. And then they will, by hand, provide that data set for me and email it to me like 2 days later. So it wasn't in enough time for today, but if you actually want to do text analysis of all of JPE, your access to JSTOR makes that possible. You just can't use Constellate. Constellate will only give you the stuff in public domain. But we have a bunch of metadata, and that is enough for us to do a bunch of analysis. So we are supposed to quit for lunch in 15 minutes, so let me see how much more I have here. I have a lot. Okay, but I can give you the hits. So the bracket operator, we've seen the bracket operator so far like an array, like a list. You can do blah, 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 bracket 0 to get the 0th member of the list. Then we saw also with dictionaries, like we had like professor, bracket, quote, name, etc. And here we saw df full text, so give me the full text column. So if we pass a string in the bracket operator, we get the entire column, right? So if I do df, so I just to sort of demonstrate this, single column name string equals doc type as a string. I do df single column name string, which is the same thing as typing df doc type in quotes here, and we get this series, right? If we pass in a list of strings, so a list, doc type and doc subtype, and then we pass that in between the brackets of df, we get 2 columns. And we get this cute little extra interface, which we don't have to worry about. But we get 2 columns. And it looks a little bit different because this is now actually a data frame and not a series anymore. If you start thinking maybe a data frame is just a bunch of series stacked together, you are correct. That's what it is. That's why Pandas provides those 2 types, a series and a data frame. A series is 1 column. A data frame is a bunch of columns. Like I don't know why I want to talk about this in linear algebra terms, but it's like you can break up an array into a bunch of column vectors. If you don't know what I mean by that, I am happy for you for not having to take in linear algebra. If you pass a series into the brackets, then you can use that as a way to filter based on true-false statements. So here I just do this little thing. I do df doi equals some doi. Now I actually know that this is a doi that is in the data set. So it says false, 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 right? But there's actually one little value in the 13,000 that is true. And so if I do print type, so if I just do this print types, we see that df doi equals blah, 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 which means do a search. True, false, true, false, true, false, true, false, whether the DOI value, sorry, I'm saying this a little bit opaquely. Let's go back up here. df DOI equals this DOI. What this means is let's create a test with an answer of true or false, where for each row is the DOI column equal to this value or not. DOIs are unique. They're supposed to be unique. So at most, it should be the case that there's just one true. We don't see it here. All we see are falses. The true is hidden in here. It's there, trust me. But what we get out of this is we get a series of trues and falses because we created a test. We didn't do equals, we did double equals. So this creates a series of true falses. This is a little bit weird because above, when we did like my name equals Pikachu, we got true or false. Whereas now we get a stack of trues and falses that are a series, which are that data type I described earlier. So if I do the type, if I get the type of df doi equals this string, we get that it's a series. And then I added just what's the type of df is a data frame. The point being that these are both built into Pandas, not into Python. So now if we do df doi equals blah, 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 and put parentheses around it, just to sort of collect it as a single expression, or as a statement, one of those, and then add value counts to that, we see that it's false 13,472 times, and it's true once. Like I said, I knew that there was one true in there. Now, if you take this series that we create this way and put it into the brackets, so now note it's df like this. So I just copied this, what's inside the parentheses here, and pasted it in here, and press play. Then we get a data frame of one row for which that is true. So this is a way to filter things on the fly extremely quickly. This is a very weird way of doing things. Normally you have to, in other libraries, you have to run functions like filter, blah, 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 blah. Here you can kind of do it all in one line. It I've done Pandas workshops for 5 years now, and it still breaks my head because it makes sense, and it's actually even a little elegant, but it's very weird. And it's okay if you don't completely get it at first. And I still make mistakes based on it because it's so weird. So I was using this df, this double bracket notation up above when I was trying to get use not null as the filter. Show me everything where the publication date is not null. So that's the filter, that's the test. I get that list of true falses, and then use that to create a new data frame based on those trues and falses. Okay, the last thing is even more complicated, which is grouping, which is sort of like using pivot tables. If I look at the creator, why did I talk about creators here? Oh, this we actually have to do. If I look at the creators, no, I thought I created by publication. Oh, I do down here. Okay, so we have to use, we're going to do a couple things here with the grouping. So the first thing is I'm going to look at the creator column, because ultimately we want to see, we want to learn about female authors in JPE. So we're going to be needing to look at the authors. So if I look at the creator column, we see that we get none if there's no creator. And if there are one or more creators, it looks like a list. You see the brackets. Bracket means list, or the bracket operator. So are they an actual list? So this iloc is give me the 1626th row, plus minus, which is this row here. So if I run this, I get, oh, it's a list. It says it's a list, and the value is two things, Paul T. Homan and David W. Noble. So another way I can do this is I can write a function called getAuthorCount that takes the creator value of the row. And I know this is moving kind of quickly, but a lot of this is showing problem solving in action, and the syntax type stuff is not quite as important, I don't think. So I create a function called getAuthorCount that takes in a row from the data frame that I call row, just like chocolate earlier. I called it row instead of chocolate. And then I take the row creator, so give me the value of the creator for that row. So give me a row, pick creator, and that's a list. Lists have length. Give me the length of that list, and that is the number of authors. So in this example, 1626, the length is 2, Paul T. Homan and David W. Noble. So this is a way that I can, if you give me a row in the data frame, I can give you the number of authors that it has. So far, so good? Okay. And then return is return the number of authors. I haven't shown return values yet, but in the previous examples of functions that we've had and for loops that we've had and so on, well, this is important for functions. In the previous examples of functions that we've had, I've used just print. Print is actually something that in quote unquote real code you never use. Because print is basically just something you use when things break and you're trying to walk through your code and say, well, print the variable at this point so I know if I'm doing something wrong or not. Because what you're actually usually doing is passing variables around from function to function. So the way you pass number of authors that you create inside the function, the way you pass that to the rest of the world is you do the return value. So I'll just do that really quickly. So I'll define a function called add2, and it takes in a number n, and it returns n plus 2. Okay? Oh, why did that not work? Oh, because I wrote returns. So it's a very simple function. All it does is it takes in a value n and it returns n plus 2. So now if I do if I add a little bit of code here and I do add to 10 and run it, I get 12. Now, I can also do print add to 10, and it looks the same. That's because in the notebook environment, evaluating a variable, evaluating a function and printing the thing looks the same, but is actually conceptually something different is happening here. And the way I will show this is by doing z equals add to 10, and then print z. So what I'm doing here is I'm assigning to z the return value of the function. So that's why that return is important. Because when the last line of the function is print blah, 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 then that function just sort of dies. It doesn't do anything. Whereas if it returns something, it gives me something that I can then assign to a variable and use later. And that's important because in the very next line, what we do here, oops, I never ran this line, is I prove that number of authors is the return value of get author count of this row. So I find the specific row 1626 with df iloc. Iloc stands for index locate, and 1626 is the index, which is effectively the 1626th article. It's one off because of zero indexing, but effectively. And I call that hominin noble. Then I do number of authors equals get author count of this row, hominin noble. And then I say print the number of authors, and it's 2. So this is just sort of proof that my author count function works. I pass in a row, and it gives me the number of authors for that row. Each row is a article. Yes?
I did that, and it's showing me an error which says trace back most recent call last.
What does it say at the bottom of the error?
The int object is not callable.
There may be, let's keep moving and see if, because this is sort of messing about still. So we'll see if when we're actually making changes to the data set, if you still have problems, and then I'll look at that. Okay? So all this is to say is that then I am going to create a new column with this line of code, and I'm going to explain in detail. So there is no column called author count. So df bracket quote author count refers to nothing. There is no such column. But it's okay because I'm not just referring to it. I'm about to assign something to it. And what I assign to it is using the apply method, which is a function that I'm passing 2 things into. And this is a little bit just so you can see it happen, because this apply is very tricky to wrap your head around. So what this means is I created that function get author count. If you pass me a row, I will give you the number of authors from that row. I will count the number of creators that it has. And then what I'm doing here is I'm saying create a new column in the data frame called author count, and in it pass the result of running get author count on every row. This is going to crash. The reason it crashes is because if we go back to the authors, we see that a bunch of them are none. None is Python's version of nil, or null, which has no length. It's not length 0. You might think maybe it should be length 0, but it isn't. There is no such thing as length of none. So instead, I have to go back to the function, here, length none, proof that it crashes. And I have to add a little error thing, which is if the creator is none, return 0. Otherwise, return the length of row creator. So this is just a little bit of error checking. These sorts of things happen when you are making assumptions about your data as all being of one type, but it actually isn't, you have to handle different situations. So if the value in creator for that row is none, return 0. Otherwise, it's a list, so take the length of the list. And now if I do this, whoop, oh, it's because I didn't press play here. So that whoop was early, but now whoop, it works. And if I do describe, we now have a new column called author count, and we can see that the mean is 1.49 authors. So we know that the average number of authors, so Vanchika, did you get this far? No? OK, well then I'll have a look. And in the meantime, think about whether these numbers make sense or not.
Did you do this one?
Yeah. Wait, I don't think I have the DM.
OK, that's right.
I did.
So that's fine. I don't know why the stuff in between didn't work, but it's just it illustrates. The point being, it's not obviously worth going through, figuring out specifically what happened.
Does it depend on like which function I run?
It could be that you forgot to run one of the things and somewhere things got out of sync, but the point is right now you're caught up. OK, so I'm really running behind here. So we see that the average number of authors is 1.5. The minimum is 0. Who knows how that happens? And the maximum is 16. Next, grouping. I'll maybe describe it during the third thing. But what I'm doing here is I'm making like a pivot table where I'm saying collapse, break up the data frame into all of the rows that have the same publication year. So it's about 100 different values. It's a little bit more than that. And you can see it's this, this Pandas thing called a data frame group by. But what this lets us do is I saved that grouping as pub year group. So now it's a new type of thing that you can't really see. It's this kind of interstitial in-between thing that is the whole data frame, then grouped by publication year. So everything from 1931, all the articles are together. And then I can ask for things about those things. So I can ask, for example, what is the maximum number in author count for each publication year? So the maximum number in 1900 was there were 1 or more articles that had 5 authors. In 2017, there were 1 or more articles that had 6 authors. I can look at the average, and I can see that the average number of authors in 1900 was 1.575. The average number of authors in 2017 was 1.58. Better, I can plot it. So, you know, whether this is meaningful or not, actually looking at this, we'll see that it is a little bit meaningful. But we can see that like something happened in 1970 that made the average number of authors completely collapse. I don't know, maybe JP was just like publishing Milton Friedman over and over again all by himself. Who knows? But for some reason it collapsed and then picked up again. And then I can I can plot also the number of articles per year. So I just picked ID because that's something that every single row has a value for that. And then instead of doing mean or sum, I just did count. So we see that they maxed out in like 1915 with over 225 articles that year. And then it's been in and out, and then slowly the number of articles that appear in JPE every year has gone down, but then there was a peak recently, you know, who knows. Now we have to keep pressing play because we are going to, so what I do is I delete, in this line, I delete everything that has no authors because I only want to look at articles that have authors. So it goes from being 13,000 rows to being 11,887 rows. So you have to press play for this one because this is going to be important for the next part of the last module. And then for this one, you can press play if you want. Do the plots change? Of course, they change a little bit, but not huge. Then there's just another way. This is another chart to see if the number of articles make articles longer, where I plot author count by word count and see that it doesn't really seem to be the case that there's much of a correlation between author count and word count. That's largely probably because the number of authors doesn't change all that much. It's under 4 typically. Now, this last line, df to Parquet. Parquet is a different data format, so this will be a smaller file than a JSON-L. We press play, and why did that not work? Oh, okay. Click on the folder, and you have to mount your Google Drive file. That's this dark folder with the little triangular Google Drive thing. It'll say, can you connect to Google Drive? And you say, yes, I trust myself. And it'll take a second, and my drive will show up here. Make sure, please make sure, here's to double check. Before you run this command, oops. Do len df. Len df should be 11,887. If it's 13,000 something, you didn't run this cell up here to remove the author count, to remove the 0 authors. If you have len 11,887 down here, I just typed this in len df, okay? Then just press play, and now it'll save this file to your Google Drive.
How do we get to so mine still shows up as 13,000?
Yes, there's a line up here. I wish I could tell you exactly where it is. Yeah, it'll be a little bit different for these aren't actual line numbers, they're actually which order you ran it in. So it'll be you right under removing data is this 3-liner here.
Which one do we remove?
You just press play.
Oh, okay.
And then it'll say df is currently 11.
I got an error actually. See.
You got an error on this one? Okay, you have to have played create the author count. Another solution is if you have this mounted, if it says drive here, you can just do runtime run all, and it'll take a second, but it'll play all of, oh shoot, no, it'll crash because I thought it was a good idea to write code that intentionally crashes. Okay, I'm going to stop recording and let you start getting lunch.